This chapter covers the following topic: addresses. Completion of this chapter will help you learn how devices are identified on a PROFINET network when a new device is added to the network, and what 3 approaches can be used when an existing device is replaced. With engineering tools such as Step 7 and WinCC and TIA Portal, a complete plant can easily be configured with a single graphical editor. To simplify configuration tasks, the editor offers 3 views. In the device view, devices are parameterized and configured. In the network view, connections between the devices are set up graphically. In the topology view, the physical interconnection of PROFINET devices is displayed. One of the initial steps in setting up a PROFINET network is to assign I/O devices to an I/O controller. A PROFINET network can have multiple I/O controllers and I/O devices. The shared device capability allows 2 I/O controllers to use the same I/O device. The editor simplifies the processes of selecting devices from the hardware catalog, creating a partial network referred to as a subnet to interconnect devices, and assigning I/O devices to I/O controllers. Manufacturers of PROFINET devices must develop a General Station Description (GSD) file for each device type. The GSD file contains information needed to configure a PROFINET device. GSD files are written in an extensible markup language XML form referred to as GSDML. When setting up a new device on a network, an engineering tool such as Step 7 and TIA Portal is used. The GSD file for the device type may already be in the engineering tool. If it is not, it must be imported into the tool. Configuration settings are then modified using the engineering tool. Once this is done, the configuration and user program are transferred to the I/O controller. Every PROFINET device on a network has 3 unique identifiers: a device name, an Internet Protocol IP address, and a Media Access Control MAC address. Collectively, these identifiers are referred to as addresses. Before an I/O controller can transfer project engineering data to a new I/O device as part of the setup process, the new I/O device must be given a device name. The device name is set using the engineering tool. A device name is made up of letters and numbers that logically and uniquely describe a device. Generally, special characters are not permissible, but a hyphen is permitted. Therefore, a device name like PLC-1 is acceptable, but a device name can be much more descriptive. For example, it can identify a machine, process, or function being controlled. As previously mentioned, Layer 3, the network layer, uses Internet Protocol IP to ensure that data packets can be routed between sending and receiving devices, even if these devices are separated by great distances and on different network types. This requires assigning IP addresses for all devices. For IP version 4, IPv4, an IP address is a 32-bit binary number which is divided into 4 8-bit groups called octets. For ease of use, the 4 octets are each represented as a decimal number with a decimal point between each of the octets. For example, 192.168.24.48 is a possible IP address. Part of an IP address identifies the network and part identifies the node. The specific breakdown is specified by another 32-bit binary number called a subnet mask. The IP address for an I/O device on a PROFINET network is automatically downloaded from the I/O controller to the I/O device as part of the startup process. Every PROFINET device is assigned a Media Access Control MAC address by its manufacturer. The MAC address is used for Layer 2, the data link layer, communications using Media Access Control Protocol. The MAC address is a 48-bit binary value that is divided into 6 octets. For ease of use, each octet is expressed as a 2-character hexadecimal number with octet values separated by hyphens. For example, the accompanying graphic shows a device with a MAC address of 00-1B-1B-0B-73-3E. The first half of this number is referred to as the Organizationally Unique Identifier, OIU, because it identifies the device manufacturer. The second half of this number identifies the device. PROFINET not only simplifies installation of a new device, but it provides 3 quick approaches for replacing devices without use of an engineering tool during replacement. First, many I/O devices can be replaced without exchanging a media card, provided the I/O device, I/O controller, and neighboring devices all support this capability. In such cases, the replacement device is recognized by the I/O controller based on topological data. The I/O controller then sends a new device name and other configuration information to the replacement device. This approach also permits rapid commissioning of machines, assuming that the network cabling is exactly done in the way of the edited topological data. Second, PROFINET devices can also be replaced by swapping a micro memory card, MMC, or C-plug. In this case, the device name and other configuration information are transferred to the replacement device with the media card. Third, in applications with an IPAR server, which facilitates automatic archiving and loading of dynamic device parameters, downloading of parameters from the IPAR server to the replacement device occurs automatically. The dynamic individually assigned parameters are referred to as I-parameters, hence the name IPAR server. What do you think? Select all the correct statements, then click Evaluate. This chapter has provided you with an overview of PROFINET addresses. This information is important because it summarizes how devices are identified on a PROFINET network and how any of 3 approaches can be used to quickly replace an existing PROFINET device.